Hi again, everybody. I'm going to redo the lab uh, discussion from today because a lot of people are asking me the same questions that I thought I answered. Maybe had bad internet, maybe my internet was bad, I'm not really sure, but people are asking me a lot of the same questions. So I want to address those issues with you now. Make sure you have your calculator, the lab document, and the data all available to you. And again, yesterday we went through the pre-lab questions. Those are due on Monday. They need to be filled in on here. If you did them on paper, then simply put your cursor down here, go to the insert menu, and that is over here. Your document may have the little arrow pointing down. Make sure it's pointing up. And you can go to insert image, and wherever that image is, you can insert it from there. Okay, so that's one little tidbit, but make sure that those pre-lab questions are here. Today you were supposed to work with your lab partners and fill in the light and the two different, light 1 and light 2, different pieces of foil length, width, and mass with the height, the heavy foil 1 and heavy foil 2 as well. I use an example with some data that I got from here. So again, the columns, at the top is the heading. So this is the length for the first piece of light foil, L1. This is the width for the first piece of light foil. And this is the mass for the light foil first piece in grams, okay? And you picked whatever team number based on your breakout room number. The data goes across. I'll go up here to the headings. So the data goes across for a single lab team, the 2 pieces of light and the 2 pieces of heavy foil. And on your lab document, instead of making it a big long string, each piece gets stacked on each other. So I'm going to go back here and look at my numbers real quick. 20.19, 15.38, 1.31. So you would put them in here. Should have already put them in there. Then in class, you were supposed to calculate the area of the foil with your partner. And that's just your very simple, the length times width, as you know. So I went over about rounding. My calculator spits out a big long number. And I don't get to have all of the digits that my calculator gives me. So I have to round. So when I take 20.19 centimeters and multiply it by 15.38 centimeters, my calculator tells me 310.522200. My numbers have 4 sig figs each. That means my multiplication operation does not get me 9 significant digits. So I have to round. And in this case, it's really easy. The 4 sig figs are the front 4 numbers. I would report this in my graph, in my data table as 310.5 centimeters squared. Okay, that's area, length times width. The next part of this is a little more complicated, I guess. You need to find the volume. And you're absolutely right. Those of you that asked me, there is no height. That's the whole point of this lab. You can't measure height. So we're going to use a formula that you should already be familiar with. Yesterday in the pre-lab questions, we used volume and density to get mass. This time we're going to use density and mass to get volume. But we have to rearrange this equation. So anytime there's a variable in the denominator, you have to multiply by it to get it to go away. And if we multiply on the right, we have to multiply on the left. So if we stopped here, this is what we used yesterday. Mass is equal to volume times density. That doesn't solve it for us. We need to do one more step. Okay, I want volume by itself, so I'm going to have to divide both sides by density. So the working equation I need for volume is mass divided by density. The density of aluminum is known and agreed upon, and that density is 2.70 grams per cubic centimeter. Okay? So just trust me, the value that was listed for this piece of foil was 1.31 grams. So now I do my calculations, grams on top, cancel grams on bottom, centimeters cubed on the bottom of the bottom, goes into the numerator. My calculator spits out 0.485185. Again, going back to my numbers, my measurements, they only have 3 significant digits. Remember, there's 0 at the end, significant because it's after a non-zero digit, after a decimal. So I need to round this to 3 sig figs. This 0 is not significant. It's just telling me there's a decimal here. Starting from the back, the 5 makes the 8 and 9, the 9 makes the 1 and 2, the 2 does nothing to the 5. I would report the volume as 0.485 cubic centimeters. Okay. Final piece to this is figuring out the thickness. So you have an area, you have a volume, which traditionally you would write like this. As we discussed previously, silly to talk about the height of a piece of paper or a piece of foil, so we're going to transfer H into a T, but you'll notice that these are the same in the two formulas. So if I take volume divided by area, I will get my thickness. Again, length times width, so it would be under here, length times width. They cancel, you're left with thickness when you're done with the volume, okay? So it's volume divided by area. So area is in your first column, volume's in your second column. For my set of data, my volume is 0.485 cubic centimeters. My area was 310.5 centimeters squared. When I put that into my calculator, it spits out, it spits out 0.001562. Again, I have to pay attention to digits. The top number, the numerator has 3, the bottom has 4. When I divide, I get the fewest. So I'm only allowed to have 3. This 0 is to tell me there's a decimal. This 0 is not significant. This 0 is not significant. These are just placeholders telling me it's a small number. We always start rounding from the back. Okay, so 2 does nothing to the 6, and we're already at our 3 sig figs. Now, you could report it like this, but you start getting lots of zeros on small numbers, it gets too big, too space consuming, and it's also confusing. So I want you to convert to correct numbers, significant digits in scientific notation. Remember, centimeters cubed divided by centimeters squared is just centimeters. Thickness is 1.56 times 10 to the minus third centimeters. Some of you may only have areas with 3 sig figs, and some of you may only have volumes with 2 sig figs because the mass is like 0.85 grams in your volume calculation. So be careful. Mine had the maximum, and that's why I get all 3. So once you get those calculations done, you input them into the lab paper, and maybe I can't do it, I guess, with, sorry, I can't, why it's not letting me do it. Let's see, there we go, 0.5 centimeters. And to do exponents, you have 2 choices. You can do format, text, superscript. That's the same thing as the little shamrock curly Q thing, and the period button. Volume 0.485 centimeters cubed. Thickness 1.56 times 10 to the -3rd. And then you have to undo it, centimeters, or the little curly Q with the period, and then just plain centimeters to get it print out. Hope that helps. Let me know why you think maybe it wasn't working for you today, if you get a chance. And we'll see you Monday.